This is an MC question that often appears in the DSE examination, which requires one to determine the slopes of straight lines. In the figure, L1, L2, L3, and L4 are straight lines. If M1, M2, M3, and M4 are the slopes of these four straight lines respectively, which of the following must be true? Questions about the slopes of straight lines are quite common in the DSE examination, so it's worthwhile for you to remember how to compare the slopes of straight lines. Let's separate the discussion into two parts. Focus on the figure in the upper right-hand side first. Since both slopes are positive, it's easy to see that the slope of the orange line is greater than that of the green line. Let's assume that the slope of the green line is 1, and the slope of the orange one will be greater than 1, let's say 2. Therefore, the slope of L3 is greater than that of L4. That means M3 is greater than M4. Because of this, we can determine that some of the options must be wrong already, including option A and option C. Then consider the case when both slopes are negative, as in the figure in the lower right-hand side. In this figure, the pink line and the blue line are the reflection images of the orange line and the green line with respect to the y-axis respectively. So the slopes of the pink line and the blue line are -2 and -1 respectively. Comparing the values of the slopes, -1 is greater than -2. That is, the slope of the blue line is greater than that of the pink line. Therefore, the slope of L1 is greater than that of L2. As a result, the answer is D. It's hoped that the use of slope 1, 2, and -1, -2 will help you remember the relations between the slopes of straight lines. Then it comes to the advanced hints part. In this question, PS is divided into 3 equal parts, such that PQ to QR to RS is equal to 1 to 1 to 1. That means Q is the midpoint of PR, and R is the midpoint of QS. As there are midpoints, we will be able to use the midpoint formula. Let's find the coordinates of Q first. They are equal to -2 plus 8 over 2, 9 plus 3 over 2. So the answer is 3, 6. Then we'll find the coordinates of S. There are 2 ways to do so. The first one is using the midpoint formula again. Let x, y be the coordinates of S. By the midpoint formula, we can form 2 equations. (8) is equal to 3 plus x over 2, and x is equal to 13. 3 is equal to 6 plus y over 2, and y is equal to 0. So the coordinates of S are 13, 0. The second method to find the coordinates of S is using the formula for the internal point of division. Shown in the figure, point R divides PS in the ratio 2 to 1. Let x, y be the coordinates of S. Let's deal with the x coordinate first. As the formula goes, the x coordinate of R, 8, is equal to the x coordinate of P, -2, times the opposite ratio, 1, plus the x coordinate of S, x, times the opposite ratio, 2, all divided by the sum of the ratios, 2 plus 1. Solving the equation, x is equal to 13, which is the same as we found previously. Similarly, the y-coordinate of R, 3 is equal to 9 times 1 plus y times 2, all divided by 2 plus 1. Solving the equation, y is equal to 0. Again, the same as we found previously. So the coordinates of S are still 13, 0. Whichever method you use, the same answer can be obtained. Just pick the one that suits the situations and that you're comfortable with.